Good morning, juniors and seniors. It doesn't look like any of the distant learners are on, so I might just have to text them. But I'm going to head down there here in a moment. If you tune in later and you see this, just make sure today all we have is quiz 1. I should have sent that to you already. If you don't have it, let me know. I'll get that to you. You can either text me or turn in later today when you turn in everything else. Remember, today is the day. You distant learners, you come in, turn in everything from the last week and this week, and then I'll try to have everything with lesson plans, any quizzes or tests next week for Bible and government. I'll try to have those for you. Let me know when you're coming, preferably after school, but if it's sometime in between, just let me know, and I'll try to have those ready for you at the front desk. But again, all we're doing is quiz 1. If you see this later or you get on after, the stream it'll be going, but I won't be on there. Remember, just take that quiz 1. If you don't have it, text or let me know you don't have it. I'll get it to you so you can take it. But that's all we're doing today. I'll be down in the classroom monitoring that quiz, and hopefully that can be a help. Hello, hello. Good to see everyone again. Good to see some of the distant learners on. Again, distant learners, if you have any questions, I think Christian, Cormel, I thought I had sent everything to you, but I just sent over all the quizzes from this last week. We had a verse quiz yesterday. That one wasn't a handout, so you just do that on a separate sheet of paper. We have a quiz today in Bible that we just took that I sent again. I thought I had sent it already, but I sent it again. And then we have a quiz in government today that I just sent as well. And I sent the quiz 1 in government if you didn't get that. I thought I had sent those to you. I apologize. It was just a little bit different. We didn't know you were distant learning at first, so things weren't as prepared. But this time, I should have all the handouts for next week ready for you after school today. But what I would like you guys to do, first of all, turn in your homework from last night. I believe that was, if you give me 1 second, I could tell you. Homework in government, I believe, was page 39, 1 through 6. I believe. If it was something different, it's all right. Just turn that in. But I believe that was the homework. Or I might have done 1 through 5. 1 through 5 on that. But turn that in. That was beginning chapter 3. We might not be able to begin chapter 3 notes today. We got to finish chapter 2 real quick. So we'll finish chapter 2. So we'll be a little behind in the lesson plan, but that's okay. We'll catch up. Finish chapter 2. Have our quiz 2 today. Remember, next week on Tuesday, next week we have 3 quizzes, so it's going to be a little bit more. But one's over Star Spangled Banner, so we should already know that, the verse 1. The second quiz will be over content of chapter 3, and then which will probably be either Wednesday or Thursday, and then Friday we have a verse quiz. Multiple verse. It'll be fill in the blank though on Friday. But we'll go over that as it gets closer. Today we have quiz 2 that should have been sent out to everyone. If you don't have that, let me know. I'll get that to you today so you can take it, send me a picture, or just turn it in person once you get here. But turn in that homework right now. Make sure distant learners, make sure you have that homework done, whatever the lesson plan says. Again, sometimes distant learners, I might assign something a little bit different in class. But it would just be easier for me, okay? Just do what is in the lesson plans that was given to you. So you might be a little ahead at times, or you might be a little behind, but that's okay. We'll all get the same work done. It's a new process. We're in different places, so it's a little bit harder to have everything in order. But just get what those lesson plans say done, and you'll be on track. But pull out your notes quickly. We'll get those done today. We'll take that quiz, and then we will be done for today. I'll probably assign some more homework, maybe an extra assignment. If it wasn't in the lesson plans, I'll let you know, and you can just write it down and do it. But we'll get that done. I believe we left off talking about yesterday with communism and how it denies humanity, right? It's always trying to take away from the authority of God and give it to man. Right? They were trying to create a new man and a new society, and at the same time annihilate millions of individual men, women, and children. But I believe we left off with this one. I'll pop it up on the screen for you. Honestly, I'm just going to go Could you guys not hear me? Hello? Hello? Can you guys, you can't hear me?
No, we can't hear you. We're seeing you move the screen or move slide by slide.
That is weird. Let me try to fix it because it says the volume's working and stuff.
Oh, now we can hear you. We got you.
All right.
Yeah, we can hear you.
Sorry about that. If they didn't get any notes, I'll just give it to them when I get down there.
All right, sounds good.
All right, sorry class. I don't know what was going on. It said the volume was going. I didn't know it wasn't working. I'm sorry. We went through those notes. I was talking that whole time and you guys missed it. Again, we're just talking about, we started with this soul of the hive and how communism was pushing this. And then we talked about the two commands given to us by the Bible concerning government. We're supposed to pray for them and respect them. Hopefully you're still writing notes down. And then civil government, whether good or bad, represents God's authority. Remember, God gave all authority of government. He gave Israel their first king, King Saul. And then I was just talking about this, how anytime if the government or law goes against God or the Bible, we always stand and represent God and the Bible over man. We have, in the picture right there, you have Daniel, a very great example for us that he stood not only once, but twice. You have Daniel, and then you also have many other people who stand for against government rather than stand for God, rather than standing for the government. Sorry, I lost my train of thought because you guys didn't hear any of that. I apologize. But again, we have examples in the Bible with that. Next note, our duty as Christians. It is the duty of Christians to, again, pray daily for our public officials, right? Whether we agree with them or not, we need to pray for them. We don't have the power to change them, but God does. If we pray for them and pray for them and pray for them, God can change them. Their heart can change, and maybe their philosophies and ideas can change as well. Just like if we had an unsaved relative, right? If we're saved, right, we believe in the gospel, what we're talking about in the Bible, the death, burial, and resurrection of our Lord Jesus Christ. We're saved, and we don't have a saved relative, or we don't know how to give the gospel, right? We need to pray for them. We pray that God will bring the gospel to our families. And just as dedicated as we should pray for that, we should pray for our public officials. Another one is the duty of us is to be informed of the issues and about the candidates so that we may vote intelligently. Okay, don't just vote who for what media or people say. Okay, know what you're voting for. So to know what you're voting for, you have to know what you believe in, know what the Bible says, to be able to vote intelligently. Next, write to our elected representatives in order to influence the legislative process. Not something we probably, a lot of us, not even me, really do. But honestly, we should probably do it more, certainly as young people. And as we grow older and into our young adult life, we should, if there's something wrong, sending a letter to a public office really does and can make a change, certainly if a large group of people do it. Next, we have separation of church and state. Is the idea that the church and the government are to remain institutionally separate. That's part of our country's policies and laws. But sadly, we're seeing today, certainly with all this COVID and everything, that's not completely the case, right? There's churches around our country are being fined because they're trying to still be open in a sense, whether they're right or wrong. But the church is supposed to be separate from the state, and that was one of our founding things. The First Amendment, it tells us this: Congress shall make no law respecting an establishment of religion or prohibiting the free exercise thereof. Okay, this is our First Amendment, and we're seeing that broken a lot today and right now in our country. Next note, the founding fathers believed in the freedom of religion, not freedom from religion. Okay? The whole purpose of us even coming to the Americas, right? in the beginning times was for freedom of religion, right? They just wanted to get away from the thought of dictatorship where they were, and the false belief of God in the Bible. So they wanted to get away for freedom of religion, not freedom from religion, because we're supposed to believe in God. Some things with that, some quotes. You have George Washington said, "It is impossible to rightly govern without God and the Bible," right? We're going to have a lot of crazy leaders if you have people that are just governing and ruling by what they think is right? Because what they think is not absolute truth. It can be very biased, one-sided. So we have to have God in the Bible. James Madison says, "Religion is the basis and foundation of government," saying, again, referring to the Bible. It is the basis and foundation of government. It teaches us how government is supposed to work. The Bible does, even in old times. John Adams, "Religion and virtue are the only foundations of a republicanism and of all free government." Right? The idea of any dictatorship is honestly somewhat against the Bible, in a sense, because God put for us to be able to have a free will, but He did put laws for us to live by. And for someone to make us do things is wrong. But for us to have a free government and to do it from religion and our faith in the Bible is how we should. Next note, 72. The only way for a nation to honor God is for its leaders to practice His principles. The only way to ensure that His principles are practiced in government is for Christians to be part of the government. Okay? So that means some people, honestly, we don't have as many as we probably should. But Christians should be involved in government. A lot of times people think, oh, we hate government, we hate politics, so we just stay away from it. No, Christians should be part of it, whether you're actually part of a real line of government, or you should be aware and be participant in government. You should know about it, research about it, stand for what is right. But more people should join politics as Christians so they can have or influence with a biblical perspective. 73, God has given to both the church and the government certain divinely appointed tasks. Rightly practice, the doctrine of the separation of church and state permits both institutions to perform their God-given duties without interference. Again, just talking about God has given us the freedom to have and to come together to worship and learn and grow about Him. And to take that away from us is wrong. 74, it is the responsibility of all Christians to pray, vote, speak out, and serve. Again, we don't do any of these in a malicious or evil, content way. Okay, this is supposed to be done through love. Just like God so loved the world, we're supposed to show God through love. Even if things make us angry and stuff like that, we should show God in how the Bible talks about with love and understanding and patience, right? There is a time to speak out and there's a time to be more aggressive, but we're supposed to represent the attributes of God. We're supposed to pray for them, care about them, vote for what is right, what the Bible says, speak out what's against the Bible, and serve. Be a servant and be willing to do things for others. 75, both Joseph and Daniel served as governmental bureaucrats. Joseph, right, he was sold into slavery by his brothers, and he started a slave, and he slowly grew. And by the end of his time in Egypt, right, he was second in command. He grew in government as well. And obviously Daniel, he started his life as a captive by the Babylonian Empire, but then later on became one of the highest advisors to the king, and that is what happened to his life. 76, the American civil government is directly dependent upon the ability of individual citizens to govern themselves under God. Again, the American civil government is directly dependent upon the ability of individual citizens to govern themselves under God. Okay, for us to be able to govern ourselves under God, we have to know God. We have to know his thoughts, which we have to read the Bible to be able to do that. 77 is the character of the American people is the cornerstone of American government. I believe that might even be in our quiz. I'm not 100% sure on that, or in a homework or something. The character of the American people is the cornerstone of American government. I think that was in a homework I graded last night. 78, good civil government begins with proper self-government, with individual self-control and self-discipline. Okay, for us to have good civil government, it begins with proper self-government. So with us, how we are acting and being with individual self-control, for us to be able to control ourselves when we don't agree with something, and to self-discipline ourselves in trying to find the right way to solve a problem, which we're seeing a lot of things that aren't right and aren't civil, and people aren't having self-control or self-discipline in our country today with all the craziness going on. Some quotes, and then we are done. Alexis de, if I say his name right, forgive me, Tocqueville, or however you say it. Liberty is impossible without morality, and morality is impossible without faith. So our government is impossible basically without morality or having morals, and to have the right morals or morality is impossible without faith or the Bible. George H. Nash says, liberty alone cannot instruct us how to live. It is what we do with our liberty that will determine our own and our country's future. It will determine our future and our country's future. Again, not just liberty, not just government can instruct us. We have to have the liberty and freedom to know the Word of God. Psalms 33:12 says this, blessed is the nation whose God is the Lord, and the people whom he hath chosen for his own inheritance. Okay, so God blesses those nations that are following him, right? And that's why it's sad today to see a lot of our country be going away from and deciding to live their own life, or a lot of people even living in hate of God. They hate the being of God, the idea of God, of there being a supreme creator. They hate that, and they believe against it. In Proverbs 14:35, righteousness exalteth a nation, but sin is a reproach to any people. Hopefully we know that by now. And last note, nothing is more vital to the health of our nation than the consistent testimony of its Christian citizens, by word and by deed. Again, it is our job as Christians to be an impact in this world for that which is right, not what we believe, right? I can have my own opinions in something, but that doesn't make them right, but what the Bible says about this. How can I show them in love and patience what the Bible and what God says about this, how we're supposed to live, right? And we're supposed to be that witness. We're supposed to be telling the gospel like we learned in Bible. But that is the end of chapter 2. We're about to take a quiz on some stuff in chapter 2, not over what we just did, but in stuff from chapter 2 from yesterday and a couple days before. If you don't have that quiz, let me know. I'll send that to you right now. I think I just sent Christian that. I think I might need to get Christian Halsey both quizzes, the Bible and government one, but I'll do that once I get down there. And once I get down there, we'll take the quiz. I'll hand it out. Make sure you turn in that homework, have it out and ready so I can grab that, and we will begin. I hope you guys have a great weekend. Again, if you have any questions, let me know. Distant learners, come later today. Let me know what time so I can try to have that stuff ready. To the best of my ability, I'm going to try to have every handout out. Distant learners, I am missing a few assignments, but hopefully you're turning those in today so I can get those grades in and not get too far behind. Again, any questions, let me know. Contact me. Let me know what you need. If I forget something, it's okay. It's the system. I'm not perfect. I'm not even close. I'll try to keep on sending them to you via email or something if I don't get them printed. But let me know if you need something. I'll get that to you. Thank you guys so much. Hope you have a wonderful weekend.
All right, welcome to chemistry. We are on 2.4. 2.4, we're dealing with atomic number, mass number, isotopes, and ions, and it's a lot to cover in one section, and there's really no other way to title this section, so here we go. We're on page 13 of your supplement, page 30 of your textbook. So page 30 of your textbook, page 13 of your supplement. Make sure you're there with me. The first thing we need to discuss about, well, actually, let's just start out by dealing with this. Two types of subatomic particles, protons and neutrons, may be found in the nucleus of an atom like we discussed yesterday. The number of protons in the nucleus determines the identity of an element. A hydrogen atom is any atom that contains a single proton. A helium atom, 2 protons. A lithium atom, 3 protons, and so on. An atom of lead is recognizable because it has 82 protons in its nucleus. If a nucleus does not have 82 protons, it is not lead. And any nucleus with 82 protons is lead. That's how we define it. There are several forms of lead, but all must contain 82 protons in their nuclei, or they are not lead. It's that simple. This is how basic this is. And so the number of protons in the nucleus is the atom's atomic number, represented by the capital letter Z. The atomic number is often given the there we go. All atoms of the same element must have the same number of protons and hence the same atomic number. This determines the identity of an element. Whatever the atomic number is that element. So I just handed you, and I didn't bring one up with me. Okay, well, I guess I'm using the website today. I just handed you guys a periodic table. All right, so that periodic table is actually from this website, ptable.com. Has a dark mode. I mean, they've done so much work on this since I taught this class last. I was really excited when I went on here yesterday. But this right here is really a great tool. And so you guys have the printable version, basically, with a couple additional notes from me. Okay, and I'll discuss those in a little bit. But for right now, what we can see is this periodic table. And so on this periodic table, you'll notice that let's just go ahead and talk about hydrogen. All right, in the top left, you have the atomic number. That's how many protons that has. If I go to scandium, scandium has 21 protons. Lithium, we mentioned earlier, has 3. And so that's what this larger, every size is relative on here, okay? The larger top left number is on this periodic table. That right there is your atomic number, okay? That is how many protons are in this material. Now, as you can tell, probably just from looking at my screen here, this right here is a very detailed periodic table, and actually it has so many layers. Like it lists the melting point and boiling point of straight lithium. You know, you can actually look. It will actually direct you straight to Wikipedia to where you guys can learn more about an element. And I just find that cool. Maybe I'm a big nerd. I'm okay with that. I teach math and I work with tech. What were y'all expecting? Okay, but basically what this shows here is your periodic table. And so this is really useful for if you're at home doing your homework or something like that and you forgot your periodic table here at the school. However, this is not allowed on quizzes and tests. It gives a little too much information. So the paper version is what you have to use for quizzes and tests. Again, do not write on your periodic tables. If you're a distance learner, I put the PDF in Google Classroom so you guys can download that and print it at home. If you don't have a color printer at home, it's got accessibility features, so if you do print in grayscale, it'll still work. That's where I was trying to go with that sentence. If you would like a copy from me, let me know. All right, so with that in mind, this site is actually extremely useful, and I'm actually extremely excited to be able to start using it with you guys. But one thing I want to point out right away, and this isn't going to be a discussion on the periodic table. I've already gone on about it too much. I actually like using the periodic table in chemistry because it helps a lot. But one thing I want to point out is the periodic table shouldn't look like this. It really shouldn't. The way it should actually look, and I love the fact that this site will animate this, okay, is, let me move that to the top so we can see the periodic table. That's how the periodic table should look. But as you can tell, that becomes a problem when you're trying to print it on a sheet of paper. For a poster, yeah, absolutely, that'll work great. Okay, that could be like the whole back wall of our classroom. I've thought about it. Okay, however, okay, this is very inconvenient to print. So what we do is we take these center 2 rows of elements, and we go ahead and, oops, yeah, that's what I want to do. and bring them down below. And so that's why there's that gap there, okay? We're not trying to be sneaky. We're not trying to do anything other than make it fit on a sheet of paper, and it just so happens that makes it work a lot better. So anything in this row actually belongs in row 6. Anything in this bottom row belongs in row 7, okay? And hopefully, again, that's made clear. There is so much more detail on this thing than even I can get into right now, even when we discuss the periodic table, okay? And these guys allow you to do a lot with their materials. So I'm excited to be able to use this as a tool, but this is what I will be using. It's called ptable.com. Ptable.com, that's really what we're going to be using anytime I'm demonstrating something with the periodic table. But I do want to pull up here it is. Your PDF very quickly. Sure. All right, I want to point out a couple notes. Right here on the top, round atomic masses to 4 significant figures for Abeka. Because all our problems are using the Abeka textbook, Abeka and their periodic table rounded everything to 4 significant figures. So you'll notice beryllium here has 5. Well, we're only going to use 4. Okay, now make sure you round appropriately. So beryllium would be 9.012. Magnesium, you'd use 24.31. Okay, so we're going to only use 4 significant figures in this class, just so that way we're all on the same page. Second of all, you'll notice I added a diatomic label to many elements. We'll discuss what that means later. But if you see a small d in certain elements, that means that when they exist naturally, they exist in a diatomic form. Again, we'll discuss that more later. But I wanted to point out those 2 additions that I have made. Mostly the diatomic notation for the elements themselves, and then this note up here to make sure you round to 4 significant figures for Abeka. So just mentioning that there, but let's go ahead and get back to this. So that's atomic number, and I should not have closed that. I am really bad about just like closing things that I need. Cool, there we go, because I'm gonna need this again on like a slide. All right. Mass number is the number of nucleons, which means both protons and neutrons. This number must be a whole number, okay? Now, the mass number of an element is not its mass, okay? For example, oxygen has 8 protons and 8 neutrons in its most basic, standard, readily available form, okay? And 8 electrons, okay? It has 8 of each. So, pretty easy to remember. Well, the atomic number is 8, because it has 8 protons. The mass number is 16, because there's 8 protons plus 8 neutrons. You have to add them together. The mass number is not the number of neutrons. It's the number of both protons and neutrons. Now, that is not the atomic mass. We'll talk about atomic mass in 2.5, but I'm just going to point this out here. You'll notice these atomic masses. If we look at oxygen, carefully without accidentally going over anything else, you'll notice it's 15.999. Okay, the mass number is going to be extremely close to the atomic mass, but it will not necessarily be equal. Mass number has to be an exact countable number because we're counting particles. The atomic mass is a measurement of it in atomic mass units. We'll talk about that in 2.5 here in just a minute. Okay, so just making sure you guys pay attention to that difference. The mass number is the number of nucleons, protons and neutrons, and it must be a whole number. Now, an isotope is an atom of the same element, which means it has the same number of protons, but a different number of neutrons. Okay, and so we're going to pick here on carbon for just a second. Oh my, okay. That's a thing. Okay, cool. There's way more isotopes than I thought. But we can have several different isotopes, which are just atom of the same element, but with different amounts of neutrons or different mass numbers. Just to give you an illustration here, okay? Carbon is one of the more common ones. All these things you see here are different isotopes of carbon. There's multiple different variations, and the difference here is the number of neutrons. Okay, the 2 most common are carbon-12. This is our everyday carbon, and you'll see how it's written there with that 12,6C. That 12 is the atomic number, the 6 is the atomic number, the 12 is the mass number, and we call this carbon-12. Okay, that is one of our more common ones. As far as that's the most readily available carbon. This is by far the dominant one. But one you've probably heard a lot about as well is carbon-14, which is radioactive. Ever so slightly. It's just beta decay, nothing to worry about. We'll discuss radioactivity in chapter 17, but just trust me when I say not too bad. Especially with the low levels we're talking. So with that being said, these are isotopes of carbon. Now, of course, there's many others. We can have as mass number as large as 22 or as small as 6, apparently. No, that can't be right. Small as 8. Okay, but 12 and 14 are by far the predominant ones, with 12 really being kind of the average carbon, if you want to consider it that way. Okay, and so the way we word it is we'll just either write the word carbon dash 12 or 14, or we'll use the notation that's shown here in this left block. This is 12 over 6. It's not a fraction, but it's mass number over atomic number. And then, of course, the chemical element symbol. And so that's how we represent that there. Again, I'm just on the isotopes tab here at this periodic table. Okay, just making sure it's not a tech issue. All right, so, whoops. So that's what an isotope is. Okay, basically it just has different number of neutrons inside. Now, we can easily find the number of neutrons by taking the mass number and subtracting the atomic number from it. And that would give us the number of neutrons in an element. For example, in carbon 12, well, 12 minus 6, that gives us 6 neutrons. In carbon 14, well, 14 minus 6 is 8, so that's 8 neutrons. And that's part of what makes it unstable, but again, not part of this discussion, just letting you know what they are first. So, a couple examples of lead. Assuming I'm on the right program. The first example is we can do 206 and 82. Okay, lead 206. So that's how I'm just going to keep writing it or saying it. We say it as lead 206 regardless. And so our atomic mass number is 206. Our atomic number is 82. And so then the number of protons would be 206 minus 82. So we get 124 neutrons. If I look at 210, lead 210, well, again, same number, same atomic number, same number of protons, because that's what makes it lead in the first place. And oftentimes the atomic number will get left off the notation in some books. We include it for clarity, mostly because then you can just look at it and know exactly where to look on the periodic table. Okay, and we write that as lead 210. Now, just to kind of give you guys some sort of scope, these are all the many different isotopes of lead. Okay, so clearly we can have many different isotopes of lead, okay, and I just want to show you guys that. I love that this thing has where it can do that. Anyway, yes, I'm geeking out over a digital periodic table, don't judge. Okay, but that's just an illustration. We're only going to mention a couple of the common ones in this class because that's all we have time for. Okay, so anytime they're relevant to an everyday discussion or to something we're immediately discussing, we'll discuss isotopes as they are. Otherwise, we're going to assume it's the average everyday element, and we're going to move on from there. Which, by the way, is still an isotope, but again, moving on. All right, now, then there's an ion. Okay, so let's back this up a second. We have atomic number that determines identity. We have mass number, which determines isotope of the identity. And then we can have an ion, which has nothing to do with the isotope or identity. Instead, it deals with an atom's charge. Okay, so these are atoms or molecules having a different number of electrons than protons. Okay, so if the charge is not balanced because there are fewer or more electrons on an atom, we have an ion. Now, an ion, anion, that's how you say it, is a negative ion. Okay, a cation is a positively charged ion. And the way I remember this, cat, happy, internet. Okay, I don't know. Whatever works for you, or cat equals internet equals happy, I don't care. Whichever way you remember it, okay, or a negative ion, you can remember it as anion as an abbreviation that way. Whichever way helps you, as long as you know one, you know the other. Okay. I'm not even a cat person, but like, that's how I remember this. Okay, so cation is really how we look at this. So let's start looking at how to work with some of these. So example 2.1, write the nuclear symbols for the isotopes of silicon having 14, 15, and 16 neutrons respectively. Okay, so the first thing we're going to do is we're going to deal with 14 neutrons. So first of all, find silicon on your periodic table. Okay, if you still haven't found it, just to make sure, we have silicon as atomic number 14. Okay, so we have atomic number 14, that's silicon. Okay, so we know silicon is going to have 14. Well, if it has 14 neutrons, 14 plus 14 is 28. So I'm going to have 28, 14, silicon. Okay, great. Now for 15 neutrons, well, okay, I just add one. 29, there, done. 16, add one, done. Okay, we don't have to keep refiguring that out once we have a baseline. All right, so that's really how we write the notation there. Now, we're going to ask in part B how many protons, neutrons, and electrons are in each of these isotopes. Well, there's no charge listed here, so we can assume that the electrons and protons are balancing out. So first things first, protons. Well, that's the atomic mass number, so 18 protons. Done. That was easy, okay? Then neutrons. Well, now we're just going to take 40 minus 18, and actually, fortunately for us, it's kind of already in subtraction notation, so just go ahead and do 40 minus 18 real fast. And we get 22 neutrons. Great. Finally, no charge again, so 18 electrons. That's how we know that. In number 2, we're given carbon 14. Well, carbon has 6 protons. Says it right there on the number. 14 minus 6 is 8. So 8 neutrons. No charge listed, so 6 electrons. Cool. Hopefully this is starting to make sense. Number 3, we have a negative charge listed. Now, we write charges a little weirdly in chemistry, and I'm going to go into that more here in just a moment. Did the book already do this? Yes. Okay. So I'll go through that here in just a moment. I'll write on the slide. But this right here has a negative 1 charge. Okay, so that means we're going to have 1 more electron than protons because remember, electrons are negative. All right, so first of all, 53 protons. This is just our atomic mass number. Okay, then 131 minus 53 gives us 78 neutrons. Now, again, looking at my electrons, I must have an extra electron because my ion is negative. Okay, so because my ion is negative, okay, I'm going to have an extra electron. So if I have 53 protons plus 1 is 54 electrons, okay, because it's a negative 1 charge. The weirdest part about this is seeing a negative charge and knowing to add an electron, okay? That's kind of the weirdest thing, but you have to remember you're adding a negative. All right, now we write charges a little odd. Let's say I have oxygen. Let's say I have oxygen, okay? And let's say it is ionically bonded with something. If you don't know what I just said, don't worry about it, okay? But let's just say it has gained 2 electrons that it wants. Well, then it's not just going to have a negative charge, it's going to have a negative 2 charge. But we don't write negative 2, we write 2 negative because chemistry, okay? I didn't design it, that's just how it is. Okay, so your book mentions it there. If we had calcium losing 2 electrons, then it would be a 2 positive charge, okay? If we have a charge, we have to put positive, okay? I know with numbers, we don't have to write positive because it can be understood, okay? But we do have to write positive when we mean charge because no sign means no charge in chemistry. Okay, so if I just write sodium, okay, that is assuming no charge. The second I put a plus, that means now it has lost its valence electron. Okay, and again, I'm using some terms we'll define later. Okay, but that's just kind of the notation we want you guys to know right now. All right, so that's 2.4. Let's go right on to 2.5. 2.5, we're on page 33 of your textbook, page 14 of your supplement. And I've already alluded to this, but atomic mass is measured in atomic mass units. And you're like, well, that's helpful. Okay, there's a reason why we made a special unit just for atomic mass. The first of all is, let's define it. Okay, one atomic mass unit, often abbreviated as either AMU or U. I think in this book I have it as U until I forget, and then it's AMU. It's the same thing, okay? But 1 U is exactly 1/12 the mass of carbon-12, okay? Using that notation. An atom having 6 protons, 6 neutrons, and 6 electrons. Just to be extra clear in our definition, we mean it's exactly 1/12 of something with 6 protons, 6 neutrons, 6 electrons, okay? And the reason for this, okay, well, actually, hold on. So 1 atomic mass unit then is approximately 1.6605 times 10 to the negative 24th grams. Now, there is a reason we did this, and we'll discuss this in a later section, but the reason why we did this is because then if we have an exact number of these things, our atomic mass units on the periodic table would also be the number of grams, provided we have a certain number of stuff. So it's to make sure the numbers are really easy to work with. Don't focus on that too much. Just worry about this for now. Now, atomic mass is approximately equal to the atom's mass number, but they are not the same thing. Okay, I showed you that already with oxygen. Okay, atomic mass number is 16. The atomic mass is 15.999. Okay, and no, you can't just round. Okay, actually, I think in our book you do round to 16.00. But anyway, that's a moot point. That's not the same thing. So carbon, for example, would be 12.01, not 12, because that's exactly how that works. Now, we can use a mass spectrometer to separate materials into ions, which are then deflected by magnets. Heavier substances are deflected less, allowing separation to occur. This is recorded as a mass spectrum. All it's doing is it's separating everything out by, okay, in layman's terms, weight, but reality, mass. Okay, and so that's what's happening there. So let's do. All right, so this is kind of what happens in mass spectrometer. Obviously, they've refined it. This is an oversimplified version. But what we can do is we can send a substance through this material, and what will happen is with this magnet and the ions, we can separate it out based on how heavy it is. And an example of this would be if you're on the highway. Okay, the wind tends to affect a car's path, assuming no correction is taking, more than a semi that's fully loaded. Now, semis tend to react more because they have a harder time controlling it because there's more overall force. But this is the analogy that's used. Okay, between the class behind me, recess outside, and a teacher on the other side of me. Hopefully you all can hear me okay. All right, so average atomic mass is usually just referred to as atomic mass. This is the weighted average of naturally occurring isotopes. So this is why carbon, even though that's where our definition is, you'd think that would be exactly 12, because we just said it's the result of taking a carbon-12 atom, dividing that mass by 12, and there's our atomic mass units. So you would think, great, that should be 12 then. Well, no, it isn't, because carbon-14 is the thing. Okay, and so you have to average out all the masses that are possible. Okay, and so we use weighted average to represent better the actual situation. So let me explain through an example here. Calculate the average atomic mass of neon gas if naturally occurring neon is 90.48% neon 20, 0.27% neon 21, and 9.25% neon 22. All right, so this is what happens, and scientists have to go through this. And so we'll do what's called a weighted average, much like we do with your grades here at the school. With your grades at the school, we average all your homework, and then all your quizzes together, and then all your tests together. And then your homework is worth 25% of your grade, and your quizzes are worth 25% of your grade, and then your tests are worth 50% of your grade. And so it's not just a straight average of all your assignments you've ever done. We weight the average based on the type of assignment. Well, we do the same thing here with this. And so I'm just going to show the math here. Okay. So what we're going to do is we're going to take the percent times the mass of that isotope, and then add the percent times the mass of the isotope, and then add the percent times the mass of the isotope. And by multiplying by the percent, we're already taking the average. We're not just adding things up. And so when we do this, first of all, we can simplify. We get 18.09 atomic units represented in 100 particles of neon 20, 100 particles of neon in general, 0.057 atomic units of neon 21, 2.03 atomic units of neon 22, and then we can just add those together, and so we get our average of 20.18 atomic units. And if you look at your periodic table, that's exactly what we have. Okay, so this is how they get that number. It's not just, okay, well, this one weighs this much, put it down. No, it's we go through and we figure out the mass of every single isotope and then average them together. Okay, and by we, I mean very smart scientists who built the periodic table, not me. Okay, we're just telling you guys how to do it, but this is the same idea here. And that concludes Chapter 2. All right, so that's the end of chapter 2. You guys will have quiz 2 soon, as well as test 1 soon, I think. Sweet. Okay, so quiz 2 will be over 2.1 through 2.3. Quiz 2 will be over 2.1 through 2.3. And that quiz will be on Tuesday, because I don't like giving Monday quizzes. All right, so that quiz will be on Tuesday over 2.1 through 2.3. Monday then, I will not be streaming because we have finished the chapter completely. I will be going over the homework and things along those lines with distance learners, or not distance, the Distance Learning Center here. Distance learners, I highly recommend you just taking that day to make sure you're studied up, make sure you're ready to go. But Tuesday will be your quiz over chapter 2, specifically 2.1 through 2.3. And then Wednesday, Thursday will be test 1. I give 2 days. Distance learners, I will tell you how that's going to work for you guys. What we may do is for you guys, I may give you guys where you guys can take your quiz on. You know what, I'll work it out and I'll get to you guys, okay? Because really your testing has to be done in one sitting because it's at the computer. So I will work with you guys on that as far as how that's going to work. But yeah, that's it. So I will get back to you guys on that. But for the class, Tuesday quiz, Wednesday, Thursday, test 1. Again, Monday is really going to be question day. So if you're here at the Distance Learning Center, you need to make sure that you are ready to go with questions. You need to make sure that you're ready to go with anything you don't understand, because that's really going to be my time to work one-on-one with you before the test. Okay, and that's the idea. Your homework tonight is to finish chapter 2 homework. Okay, the assignment's already in Google Classroom. You're going to submit it the same way you have been, which is via picture. Okay, and then again, that will be returned to you as soon as I grade it. Okay, so again, homework tonight is finish chapter 2 homework. Quiz 2 on Tuesday over 2.1 to 2.3 with help day, if you want to call it that, on Monday. I'm going to try to work them into my class schedule this year. And then Wednesday, Thursday is test 1. And so really the next time I stream will be Friday of next week when we begin chapter 7. And again, we're jumping straight from chapter 2 to chapter 7. I know that sounds weird. In your supplement, you'll just keep going and our books will be flipping around. Okay? So I will see you guys soon and have a good day.
All right, guys, so we're going to get started with consumer math. We're on page number 24 and 25. This is our analytical skills section. Every chapter has at least one of these. And what it does is it gives you a situation, then it gives you 4 different options. Okay, so we're going to read through the situation here in just a second, and then we have the 4 different options. And then on the next page over, page number 25, it gives us some questions about those options. And then at the bottom of the page, it asks you which option would you choose. All right. So if you're watching online, I'm going to read over the situation. I'm going to read over the options, and then when I get down, with that, we'll go over the important fact on page number 25, and then I'll close off the live stream, and you guys are done for today. I'll go down to the classroom to answer any questions. Your homework for tonight is going to be on page number 25. Make sure you fill out all those problems, and then I want to know which one you would choose and why. All right. So our situation on page number 24 is Chad is a senior in high school. He plans to buy, with his parents' help, a used car or truck. Chad has saved $3,400 from earnings he's received from his summer and after-school jobs. His parents are willing to match his savings, but Chad will have full responsibility for car costs after purchase. He has approximately $130 per month to spend on car upkeep, gasoline, and insurance. Okay, so option number 1 here. Option number 1 is he can buy a 1992 damaged Chevy Lumina for $4,388. The car needs $1,500 worth of body repair. The state sales tax is 5%, and the registration fee for the Lumina is $46.50. The car should average 23 miles per gallon. The insurance premium will be $76 per month. Option number 2, he can buy a 1995 Dodge Spirit for $6,725, finance $500 off the cost for $25 per month for 24 months. The registration fee for the Dodge Spirit is $32.50. The car should average 20 miles per gallon. The insurance premium will be $83 per month. He can buy a 1989 Pontiac Grand Prix LE Coupe for $4,995. The car needs new tires, which will cost $280, including sales tax. The registration is $32.50. The car will average 25 miles per gallon. The insurance will be $79 per month. And lastly, he can buy a 1991 Toyota 4x4 pickup for $5,880. The truck needs some minor repairs. It will cost $175. The registration is $36.50. The truck will average 30 miles per gallon. The insurance premium will be $68 per month. Okay. The important fact that we need to figure out first, because it's going to be involved in every single one of these options, is how much cash does Chad have to buy a used car? So in order to do that, we're going to go back to our original situation. Our original situation says that he has saved $3,400 and that his parents will match what he has. So if they're going to match what he has, how much total does he have? You would take $3,400 and divide that by 2. Okay? Giving you $6,800 that he has in order to buy this vehicle. All right? So now that we have the important fact out of the way, I want you guys to look through all the analysis here for each option. It helps you think through all these options and which one would be the best for you. So which one would you choose and why? Go through all the questions and then figure it out from there. If you guys are watching online, again, make sure you come in, pick up your homework for next week, drop off the work that you have for this week, and then I will be down to class in just a minute.